All right, 289, recognizing patterns. If you're still finishing up that warm-up, that is okay. Wants to know how these are increasing. So if they're linear, usually it's pretty easy. The first two are linear. What am I doing to the front number to get the second number? Times 8, right? Taking the left side times 8. So my equation would be y equals 8 times whatever is in that first one. That is a linear function. How about the second one? Still times 8, so it's the exact same equation. Linear. Do you see the pattern for C?
They do like, you're taking it times 4.
Yeah, it's actually 4 to that power. 4 to the first power is 4.
But what about the 0 and 1?
4 to the second power is 16. 4 to the third power is 64. And actually anything to the 0 power is 1. No matter what that number is, 4 to the 0, 12 to the 0, 1 million to the 0, it doesn't matter, it is 1. How about the last one?
Adding 4.
Adding 4. Okay. But it's not just 1 plus 4, it's not just 2 plus 4, not just 3 plus 4.
Oh, more on the right side you're adding.
Yep, it's getting 4 bigger there.
I don't know.
It is something plus 4, but what am I doing to this number before I add 4 to it?
Squaring it.
You are multiplying it by 4. 4 times 1 plus 4, 2 times 4 plus 4, 3 times 4 plus 4. Okay, so knowing that, seeing the equations, and maybe you could have saw it, only one really grew in a hurry if you look at the y's. So to me, I would say this one, this is the exponential. That's going to have the most growth, and you can see that by looking at the y values. And if you just look at 4 getting plugged in there, I get 32, 32, 20, and 256. That's a big difference. And so to me, that is the one that doesn't belong. The exponential, which we're going to continue to look at. Question 2. Mr. Strang, would you read that, please?
A food company currently has 5 convenience stores, is considered 2 plans for expanding its chain of stores. Plan A to open 20 new stores each year. Use technology to complete a table for the number of stores for the next 10 years as shown here.
Yeah, I don't think we need, I think we can easily just fill this out. Adding 20 each time, it said. And we'll fill out the chart. So if I have 25, how much of a difference is that from the year before? How much did it change from the year before?
Wouldn't it just be 20?
20. Changed by 20. Year number 2, how many I got? 45. How much did that change from the previous year? 20. Next one.
65.
How much did that change from the previous year? 20. Can you fill out the rest? Okay, then some questions from that. What do you notice about the difference from every year?
21.
What's that? 21?
20 more.
20 more. It's the same number, all right? It's always 20. So if there are n stores in 1 year, so if I put an n here, how would you get the next one? N plus 20. That would be your equation. What do you notice about the difference every 3 years? So if we look at every 3,
It's 60 more.
41.
every 3 years it increases by 60.
Like 2, 3, 4, then is that 40?
I would say from the starting point to year 3, from year 3 to year 6, and so on. So what would that equation be if I had an n then, for the one 3 years later?
N times, or N, 3n times 20.
N plus 60 is fine. Right. Said it increased by 60. So that's all we need. Or you could do 3 times 20 plus n. That would be fine as well. Okay, now let's look at plan B. We're going to double the number of stores each year. Use technology, but again, I think we can fill this out pretty easily. So, starting with 5, after year 1, I will have 10. The difference from the previous year is 5. The factor from the previous year. So, what did I take at times? 2. Year 2, how many stores? Nope.
100? Or no.
We are doubling it.
Yeah, 20, yeah.
Difference from the previous year?
10.
10. Factor? 2. Year 3? 40. Difference from the previous year?
20.
Factor? Alright, continue on. Questions where any of those came from? Again, just taking them times 2. Then you're subtracting. They're all doubled. So what do you notice about the difference from year to year? What's that? Doubles? From previous year? I also notice they are not the same. Not the same number like they were last time. What do you notice about the factor? Always 2. Because it doubles. If there are n stores in a year, how many stores will it be a year later?
N times 2.
N times 2, or 2n. Both mean the same thing. What do you notice about the difference every 3 years?
It's,
Triple, or no?
no, it's gonna be different every year.
It's not the same, is it? It's not the same. You can see it's growing more and more. Can't just simply say adding 25 or adding 35. What do you notice about the factor every 3 years?
6 or 2.
What's going on in the population? What happens every 3 years from going from 5 to 40? From 40 to 320. From 320 to 2560.
You're just, you're doing it times itself. Wait, no. Well, I guess 40 to 160.
How about 5 to 40?
You're taking it times 40.
5 to 40.
8.
What?
Oh, you're counting
8. 8 times bigger. 40 to 320 times 8. 320 times 8. 2520. Now why is that? Well, because it's doubled each year. For 3 years, 2 to the third power is 8. So if there are n stores, how many stores will there be there 3 years later? All right. Take it times 2, 3 times, or just times 8. 8 times bigger. Okay, we're going to skip the are you ready? And go right into the final question there. It's going to give us 2 situations and I want you to match. There's 6 answers there. You're going to put situation 1 or 2 by them. Here are your situations. A person has 80 followers on social media. Number of followers triples every year. How many followers will she have after 4 years? So you'll find the ones that match that. Put a little situation 1 by it. Or a tank contains 80 gallons of water. It's getting filled at a rate of 3 gallons a minute. How many gallons will be in the tank after 4 minutes? So all 6 of those, you'll need to write situation 1 or 2 by them. And then we will discuss. So those six things under there, situation 1 or 2. All 6 will have situation 1 or 2 written by them.
Every single one?
Every single one.
But it only fits 1.
Nope. There's just different ways of expressing.
How do you do that?
All right, so situation one. We could actually write those numbers out if you wanted to, right? 3 times more. Year 2 would be 240. 3 times more would be 720. 3 times more would be 2160. 3 times 2160 is 6480. Situation 2, you have 80 gallons of water. It gets filled 3 gallons per minute. So after minute 1, you'll have 83. Minute 2 would be 86. Minute 3 would be 89. And 92. So let's see which ones match that. 80 times 3 times 3 times 3 times 3. Yeah, absolutely. It's going to be this one. Times 3 times 3 times 3 times 3. Situation 1. B is pretty obvious. Those are the same numbers we got there. That's situation 1 as well. 80 plus 3 plus 3 plus 3 plus 3. That's definitely 2. 80 plus 4 times 3. 4 times 3 is 12 plus 80. That's how you got 92. E is obvious. Same numbers again we have. 80 times 81. Well, 81 is 3 times 3 times 3 times 3. So that is the exact same answer as A. So 3 1s and 3 2s is what you have there. Another good comparison in the summary, page 261 or 293, looking at those patterns there. One is addition, one is multiplying, same thing that we've been doing today. So your homework starting on page 294. First 5 are from today or yesterday. 6 is a review from Unit 4. As is 7 and 8 is a review from Unit 3. So I don't think anything too difficult there. Plenty of time to work, but 1 through 8 for tomorrow.